All right, so this is probably the hardest thing today, right? Is alternating current. So this is direct current. So if we look at the voltage or the current versus time, right? The voltage also does this, right? The current just stays steady, right? With alternating current, it switches back and forth. And in North America, in the U.S. anyway, we are 120 volts. Right, and we are 60 hertz. So it does this 60 times a second. It does this complete cycle 60 times a second. Okay, and I believe in Europe it's something like 240 volts or something like that, and it's 50 hertz. I don't know. It's different, right? The interesting thing is that the entire power grid west of the Rockies is all connected together. It's all moving in unison. You can actually set a clock by it, which is kind of cool. And the formula for it is just something like this, right? It's V naught. This is not important. I don't think they have anything to do with it. But there is a peak, right? So the peak is V naught is the peak voltage, and I naught is the peak current. Okay. Now what I do is I'll do this for you. Okay, is I'll show you an oscilloscope, and if we look at our peak voltage, it's around 170 volts, right? Which of course we all think that it's 110 or 120 volts, right? And the difference is that this is really the RMS voltage. So that's what we're about today, is that when we talk about this alternating current, we average it in a way that makes it so we can use Ohm's law and we can use the power formulas that we learned. Okay, let me try to explain this. Okay, so let's imagine that we have this current, right? If we're calculating the power, we would square this. Now convince yourself that this red line is this blue line squared. Okay, so notice that every place that this is 0, that's 0, 0, 0. When this is a peak, remember if it's squared, it's positive, right? So even though it's a negative current, it's still positively squared, right? When it's 0, it's 0, et cetera, right? So this is actually this thing squared, okay? Now, notice that there's a peak power here, right? Okay? But the average is this dotted line. The average power, that little line there, is the average, right? Okay? So the average power is actually half of that peak power. And the reason that it's half is that I can cut this thing off and fill in that valley, cut this off, kind of like West Virginia, right? Okay, cut that off, fill in this valley, right? And extract all that coal, right? Nothing bad could come of that, right? So now what you got to understand, remember also, is that power is I times V, right? And so to get to reconcile this difference between peak power and the average power, okay, what we have to do is we have to think of something called RMS, right? So this is the RMS. This is kind of like a power average. Now let me show you how this works, right? Okay, if I figure out the power using this, and I multiply those together, I get I naught over square root of 2, right, times V naught, the peak voltage, right, over the square root of 2. Well, lo and behold, you get I naught V naught over 2, right, which is exactly what we know, right, that the average power is, this is the average power, right, is 1/2 the peak power, okay? So what we talk about is root mean square. When you use a voltmeter in alternating current land, okay, that voltmeter is in RMS. If it doesn't say peak, okay, it's RMS. If we mean peak, we will say peak. If we don't say peak, it's RMS. That's when we're talking about alternating current, that's what it is, okay? So let's look at the formulas that we have. This is the formulas that I use these the most, right? Okay, so this is sort of like the average. If you, it's kind of like the power average. If you want to average the current, this is what we do. It's not always the peak, and so we divide by the square root of 2, which is like 1.4 or something like that. Okay, so it's less. The RMS is less. If you've got like this, the RMS is, here's your peak, right? The RMS is somewhere in here, right? Okay. And then here they're just saying, these formulas are in there, they're just saying that Ohm's law works instantaneously. It works at the peak, it works for the averages. The maximum power, right, is the peak power, right, which, by the way, you could also add I naught squared R. You could also add V naught squared, not squared, over R. All those formulas will work. If you put in the peak value, you'll get the peak power. But remember, the average power is half of that peak, okay? Yeah. All right. So let's look at this example. I'll do this in another video.